Alright, this section is about operations with functions, and remember, if we have a function that is expressed as a formula or an equation, you can use function notation to write it. So for example, f of x equals 4x plus 2. The function is 4x plus 2. That's the roadmap basically that takes an x and pairs it with a y value. Okay, this function's name is f, and it is written in terms of the variable x. So that's kind of how we speak about it. But I would just, when referencing this function, I would just say f of x or just function f. And that implies I'm talking about 4x plus 2. Okay? In operations with functions, we can manipulate two functions with our regular operations. For example, if I want to take and add two functions together, f of x plus some other function g of x, I can write it just like you see it here, or you'll often see it written as f plus g of x, which means just take function f and add it to function g. Okay, same thing goes with subtraction. F of x minus g of x is often written as f minus g of x. And if we multiply two functions, f of x times g of x, I guess I can put a dot in the middle to show multiplication, f times g of x, and division, f of x over g of x just means, or it can be written f over g of x. This got a little caveat to it: g of x cannot equal 0, because then you'd be dividing by 0. So what I'll do is I'll write a couple of functions here. Let's call one of them f of x, and we'll make him x squared plus 3x plus 2. And I'll have function g of x, and I will call him, or let him be, x plus 1. And let's go through how you could then use these operations to write what they're equivalent to. So let's do a sum of two functions first. Let's say I get f of g of x. That means to add function f with function g. So mathematically it looks like this. There's function f, and I'm just going to add on function g. Okay, and then if I can combine any like terms, I do, and I get x squared. Looks like I've got 4x plus 3. So there is the sum of those two functions. Let's do a subtraction problem. F minus g of x. You have to be a little bit careful here. This is f of x. Now I want to subtract, and I got to subtract all of g of x, so I've got to put g of x in parentheses like that. So now I've got f of x up here, and I'm subtracting off the g of x. And what that means is you've got some distributing, or you have to flip all the signs on g of x. Okay, so you're subtracting each term, and therefore f minus g of x would be equal to x squared plus 2x plus 1. So there's addition and subtraction of two functions. Alright, let's use these same two functions now. We got next here, I guess, multiplication. So we can do f times g of x. Look like this: f of x plus 3x plus 2 times g of x, x plus 1. Okay, this is in factored form right now, almost completely factored, but we'll go ahead and multiply it out. And so we'd have to distribute the x squared. It's x cubed plus x squared. We'd have to distribute the 3x. It's 3x squared plus 2. And we'd have to distribute the 2. And that's 2x plus 2. And then we'd combine any like terms. So we end up with 4x squared we got a 2x and a 4. There's f times g of x. Division of two functions. Make sure I get all of them covered. I don't think we're doing any composite stuff yet. We will. So let's do a division problem. F over g of x would just be f of x, x squared plus 3x plus 2, divided by g of x, x plus 1. Now, division problems are probably historically the tougher ones because the next step is you have to actually try and carry out that division if you can. And so to do that, we would factor our numerator. Like that. And we can see we have a common factor in the numerator and the denominator right here, x plus 1 and x plus 1. Those are common factors, and so we end up with x plus 2. Now this is assuming that x does not equal negative 1. Okay, because notice if x is negative 1, then this function, you would end up with an undefined function because you can't divide by 0. And that's essentially how you work with function operations. There are some tricky things, I guess. You'll see some weird things like, let's say f of x. I wouldn't even call them weird. Was x plus 3, and you get hey, f of x squared. Well, that just means f of x times f of x, and so you'd have to take x plus 3 and square it, or x plus 3 times x plus 3. Don't forget, that's one that a lot of us missed when we did it. People saw and just squared each term of x plus 3, but you got to square the binomial. You have to square x plus 3, which means take it times itself. So that's what f of x squared looks like. I hope that will help you on your homework.